So in this example, we have a very similar process as the one above, but we have something called with reducing. So I'll show you there when we get there. So let's go ahead and start solving it like we've been doing. So first times last, so 6 times 7 is 42. And we are trying to get to 23. So our factors of 42 are 1 and 42, 2 and 21, 3 and 14, and then lastly 6 times 7. So which pair can add to be 23? 2 and 21. And so I write this in factored form. And I see that I have to divide by that first number 6. Now, 2 divided by 6 gives me a decimal. But I could reduce this. And if I reduce it, I know that 2 goes into both of those numbers evenly. So I would say x plus 1/3. And then here, 21 divided by 6 gives me a decimal. But if I reduce that, I could reduce by 3. 21 goes into, or 3 goes into 21 7 times. And 6 divided by 3 is 2. So what I did, instead of just bringing the bottom up, I go ahead and simplify the fractions, reduce the fractions, and now I bring the bottom up. So 3x plus 1 and 2x plus 7. Okay, part B is very similar because it's also a reducing type problem. So let's start step 1. First times last is 24. Our goal is to get to the middle number 10. So the factors of 24 are listed here to the side. Which factor or factors can make 10? We have 2 of them. So here, if I were to use 2 and 10 or 2 and 12, I'd have to subtract 12 minus 2 to get 10. And in my problem, I have no negative signs, so I can't use 2 and 12. 4 and 6 could add to get 10, and I would just keep it positive since the problem's all positive. So I write this in factored form. X plus 4, x plus 6. The first number in my problem is 8, so I'm going to divide by 8. I decide, can I divide 4 over 8 evenly? No. So I have to reduce or bring the bottom up. And in this case, I can reduce. I know 4 can go into 4 and 8. And that reduces to 1/2. For 6 and 8, what goes into 6 and 8? Well, 2 goes in evenly. So I would have 3/4. So same idea, I got to bring that bottom up because I can't have that fraction as my final answer. So I would say 2x plus 1 and 4x plus 3. And just a quick reminder that you could set up a 2 by 2 Punnett square, and you could go ahead and multiply these out. But regardless of how, or you could use FOIL, however you solve this, you have to get back to your original answer. So this would be a good thing to know to check on a test or an assessment of some sort.